So remember basic algebra, okay? So what could you do first? Divide everything by 8. Divide everything by 8. Divide everything by 8. What's 200 divided by 8? 3, 2, 1. What is it?
25.
Is it 25?
Yeah.
Good job. Boom. So what do you have here? 25 x to the negative 2 plus x is equal to what?
Yeah.
Is that easier to work with?
Yeah.
Yes. Keep going. Go. Find me a solution. Chris, move the x over. So you have 25 x to the negative 2 is equal to negative x. So that's 25 over x squared is equal to negative x over 1. What do you do now? You've done it many times in your life. What do you do? Yeah, so you get negative x cubed is equal to, so x cubed is equal to negative 25. So what does that mean the answer is? X is equal to what? The cube root of what? Negative 25. Is that allowable? Can you take the cube root of negative 25? You absolutely can. Why? Why is that allowable, but the square root of negative 25 is not technically... And also, I don't like using the word allowable because you can take the square root of negative 25. It's just plus or minus 5i.
It would be an imaginary number.
But this is not imaginary. This is real.
Right.
What's the cube root of 8? 2. What's the cube root of negative 8?
2.
What times itself 3 times is negative 8?
2 times
Negative 2.
Yeah.
Negative 2 times negative 2 times negative 2 is negative 8. Can you take the cube root of a negative number and get a real number?
Yeah.
Absolutely. So is this a real number?
Yeah.
Is it a quote? And also these are judgmental words. We like to use the words like not allow or nice, right? Is that a real number up there? Sure. Is it an easy to find decimal? Not really. You can do it by hand. It takes a long time. It's about what? Anyone want to guess? It's about what? Well, what's 2 cubed? What's 3 cubed?
27.
So what do you think that one is about? Give me a guess.
2.25.
Negative 2 point.
2.72.
It's closer to 3, right? Because 25 is closer to 27. So is that an answer that could work? Absolutely. So it says.
I got this before, but I got the same answer by just dividing by x to the negative 2, then moving it up top?
Yes, the exact same process. There's many different paths. There are many, many different paths. Your goal, Noah, is what you surmise, which is getting x's all together. Now, I like the people that tried to factor here, but does that really work in this case?
No.
Not really. You need to get them on both sides, cross multiply, and what you did is functionally the same thing. Functionally the same thing. Now, do you believe in this answer? All right. So if we check our answer, 200 times the cube root of negative 25 squared plus 8 times the cube root of negative 25. Oh, to the negative 2, thank you, equals what? 0. We want to know if that equals 0. So you do the left and see if it comes out. Pick up your calculator and plug that in. Just see if it comes out. Let's see if you can plug this into your calculator at least. The main of this function is going to be where all the numbers were what is true.
X is less than or equal to 10.
So you're solving it. I like that. That's actually really good. That's actually really, really good. But how did you get that, Noah? How did you get that?
Because I just don't want whatever's under that.
There it is. You don't want this to be negative, right? So what does that have to be? It has to be what?
Less than or equal to 10.
No, in order for it to be an okay situation, it needs to be what?
Greater than 0.
This needs to be greater than 0. 100 minus x squared has to be what? Greater than or equal to 0. Is 0 okay?
Yeah.
So therefore, 100 is to be greater than or equal to. Do we generally write it that way? We usually do something to that inequality. What do we generally do? We flip it. So it's x squared has to be what? Less than or equal to 100. Now you have to be really, really careful about this, right? You have to be really, really careful about this. How do you properly solve this inequality? What do you do? How do you properly solve this inequality? What do you do? Alex, what do you do if you want to properly solve this? You would square it? You would take the square root? Now, if you take the square root of something, what do you end up with?
Plus or minus.
Yeah, end up with plus or minus. So you have to be really careful about this, right? So you want to look where it's equal to 100, right? Where is x squared equal to 100?
10.
And negative 10, right? So what happens when you plug in 10 into that inequality? What do you get? The original, this one right here, the yellow. What happens when you plug in 10 right there? What do you get? 0. So is that okay? Is it okay if it's equal to 0? Sure. Now you have 3 regions. Which region is our domain going to be? Is it going to be region 1, region 2, or region 3? It's going to be region 2. Why is it region 2? Because all of those numbers may be true. You test one of them. Put 0 and put 5 in there, right? 5 squared is less than 100. So what's the domain of this function? If you're going to state the domain of this function, how could you state it? There's a few different ways to state the same thing, but how would you state it, Chris?
X such that X is...
Yeah. X is greater than or equal to and less than or equal to 10. Yeah. So you could state it this way, right? That's totally fine. You could also state it like this, negative 10 to 10. That's not the point 10, but that's not the same thing, right? What do I need to change those to, those end things? Brackets. That's another way to state it. That's fine. If you go to the left of negative 10 or to the right of 10, what happens? You end up with what type of number? Exactly. Right. You end up with an imaginary number. Exactly. Okay. So what does B ask you to do? Find all maximum and minimums exactly and verify which is which. Now what do you have to do? We're back into the land of what? In calculus, yeah. So find me the derivative of that function right now, everybody. Find me the derivative. Yes. You have to use the product rule. You have to use the product rule. So you could, if you wanted to, you could say that this, most of you said this is the first function, and what's the second function? 100 minus x squared to the... Most of you said that. This is the first function, and this is the second function. So if you do it in the order I want you to do it, in the derivative of the first, which is going to be what? 1/2 times the second, nothing goes away, like this, plus the first times the derivative of the second. What do you have to drop to the front if you're doing the derivative of the blue? What do you have to drop to the front? 1/2 times, same thing stays in the middle, right? To the what power? Negative 1/2, but then you have to use the what rule. What rule is coming into play now? Chain rule. You're gonna do the derivative of the inside of this, right? The derivative of this. What's the derivative there? Negative 2x, like this. So now you do have the derivative. We have the derivative. Let's do the next steps together. It says find all minimums and maximums, exactly. Why did we find the derivative if we're looking for mins and maxes? We've done this many, many times in this class, so go back a little bit. Why do we use the derivative to find mins and maxes? Because what? Equation now. We now take this and we set it, don't do this, we're going to do this all the time, we set this equal to 0. And now you have to carefully solve this. You have to carefully solve this. Like the question we just did, what could you divide by right now to make it a little easier? 1/2. You could cancel all these, the two 1/2s right here, right? So what do we have now? We have 0 equals 100 minus x squared to the 1/2 plus what? What's left now? Oh, what cancels over on the right-hand one? Something cancels. The 1/2 and the... Leaving you just with that negative, right? So what do you end up with? How many x's do you have? So what do you end up with? Minus what? Minus x squared times what? Well, the half is gone, right? Are we okay with that right there? Take a look. Are we okay with that? Okay, so if we're working on this right now, this looks kind of similar. We did something similar to this before. The exponents are a little different. Anybody want to guess what we do now? Anybody want to guess? What's one thing, Chris, what would you want to do now? What do you want to do? Anybody have a guess? Yeah, David.
Add x squared.
Yeah, so like get the things on both sides, right? So maybe you end up with this, x squared, 100 minus x squared, I like this, to the, it's still negative, equals this, right? 100 minus x squared to the what? 1/2. Let's do the same work we did before. It's slightly bigger, but we can do the same work. What did we do next on the last problem? What did we do next? We have to do one thing first. We don't have anything to cross yet, right? We have to rewrite it. So what do we do? X squared over what? 100 minus x squared to the 1/2. When you move it down to the bottom, it becomes positive, right? Equals what? 100 minus x squared to the over what? So now what can we do, David? Well, no, you just told. What can we do now? We can cross multiply now. So what do we have? 100 minus x squared to the 1/2 times what? 100 minus x squared to the... Let's write it out first. I like that you see what we're doing. Now what can we do with the powers? What can we do with these two powers now? What happens? You add them. Why do you add them? Because they have the same what? Base. So what does the left-hand side become? To the equals x. Oh, is that a nice power to have? So what is that? That's just 100 minus x squared equals what? Nope. Oh, equals x squared, sorry. Yes. Now, what does 100 equal? You're like, that was like, teacher's wrong. What does it equal now?
2x squared.
2x squared. What do I divide by? So I get x squared is equal to, so x is equal to, plus or minus the square root of 50. We needed no calculator. Now here's the point. So we asked before, like, why would you need to do a question like this if there's no calculus involved? Now we will be able to use, how many times have you found the maxes and mins of a, how, maybe an extra way to what I'm speaking, please, please. Have we found maxes and mins before? Yes. Have we worked with this type of function before? No, we haven't. We need to remember some of our algebra in order to manipulate these. Yes, what's your question?
What do we do at the end to get that answer? I'm sorry.
What do we, no, don't apologize, don't apologize. Are you okay with this right here?
Yes, and then the next line I'm good with.
This one you're good with?
Yep.
What about this one?
No.
And what about this one?
No.
I added x squared to both sides.
Oh, yeah.
That's it. No, it's fine. No, believe me. But remember, what did I say is the worst word in mathematics? Like clearly or obviously? Like it's right. You're like, well, now you see it, but you didn't see it before. So there's two potential answers, right? So what did we do if we were trying to find a min and max and we had two numbers? Remember we made what? We made the, what did we call them? So we have negative root 50 and what? Positive root 50. So this was x, and maybe we would look at the derivative, right? We'd look at the derivative and see rising to falling means it's a what? If it's rising and then falling, what does that mean it is?
It's going to hit a max.
It's going to hit a max. If it's down and then up, it's going to be a minimum, right? So we looked at the first derivative. We also looked at the second derivative, right?
Yeah.
Remember, concave up is happy, so it's a minimum. Which one do you want to use, the first derivative test or the second derivative test on this one? Which one do you want to use? These three regions, the yellow region, the blue region, and the green region. What number is between negative 50 and 50 that's really nice? Like what number is between there?
0.
0. So let's plug in 0. What happens when you plug in 0 into that red box right here? Plug in 0. You get 100 to the half. Oh wait, what's 0 times? Oh, what does this become? 0. That's just 0, right? And luckily it's 0 over a number. We don't like 0 in the denominator, but this is 0 over not, what is this? 100 negative 110. But it's going to be 0 right here. But the reason I was nebulous about that is, do we care what the rest is as long as it's not 0? And then, no, it's okay because that's 0, that's gone. Well, it's 100 minus 0. 100 to the half, what's 100 to the half? 10. So this is what? This region is going to be what? Positive. That region is going to be positive. Now we need to pick a number that we can plug in that's to the left and to the right. What number? Let's go positive. What number? How big is root 50 about? What is root 50?
7.
Like 7 something? Yeah, because 7 times 7 is 49, so it's a little over 7, right? So we can't do less than 7, we can't do 7, we should pick maybe what?
10.
Well, let's go to the pot. Let's do the green first. Let's do the green first. So we can pick 10, right? The challenge with 10, though, is 10 isn't in the 10. 10 isn't in the domain of this function right here. It's in the original. That's fine. So maybe what I like to do is I like to pick really, really big numbers and see what happens. That's one option. Or you can pick maybe 11, or you can pick something else. So what number do you want to pick? Do you want to pick? Why can't we plug in 10 into this? No, you can plug in 10 and this is 0, right? But what does negative power mean? You put it in the denominator, right? So this would be 10 over 0. Are you allowed to plug in 10 over 0 here? So let's just go one, we could go one bigger, right?
Yeah.
We could do that, right?
Yeah.
So plug in 11. Oh wait, can you take the square root of, what's 11 squared? What's 100 minus, you get negative 21. What's the square root of?
You can't do that.
You can't do that, right?
So it'll be undefined.
Yeah, so what's going on here? What's going on here, everybody? What's going on?
Oh, it's an imaginary number.
Imaginary? It would be an imaginary number, but that doesn't really help us, right? We want to know if it's positive, is it rising or falling? Get your calculators out, everybody. The domain of this function was?
-10.
So the function is only defined from what? So should you be seeing anything to the left of negative 10 or to the right of 10? No. So let's go back to here. We just said, okay, we have negative 50 and 50. So this function, what happens at negative 10? It ends right here. And what happens at 10? It ends. So if we want to pick a number to plug in, we need to pick a number that's between negative 10 and here. And we need to pick a number that's between 7 point something and 10. You remember what I'm saying? You see what I'm saying here? We have to remember our domain in the first place. We can't pick 10, even though it'd be really nice. So instead of picking 10, we need to go inside a little bit, right? So we can't pick 11. Let's pick what? 9. So if we go back to here, we're just really interested in if it's positive or negative, right? 100 minus 81, you have the square root of something here. Plug in 9 into this and tell me what you get. Plug in 9. Do that for me right now. Plug in 9 and tell me what you get. Plug in 9 and tell me what you get.
Sorry, remember?
9. First, yeah. It's f prime. I'm sorry, f prime. Yeah, see? So is it negative 14.22? Does anybody agree with that? Do we get? Yeah, I got a few. So this one's going to be negative. So what's the other number you have to plug in? So what's a prime of plug in negative 9. Now here's the thing. You don't actually need to plug it in. Look at the equation. Every time x appears, what's happening to x in the derivative? It's what's happening to it. It's being squared, so it doesn't matter if it's positive or negative. It's going to result in the same. So this is also going to be what? 14.22. So this goes from negative to positive, so it's falling to increasing. So what happens here? What happens to this one? It's going negative to positive, the derivative. It's going down to up. So is that a minimum or a maximum? It's a min when x is negative root 50. And what about this one? It's going up and then down. What is it? So it's a max when x is root 50. How comfortable are you with what we just did? Use your hands here. How comfortable are you with what is that? What do you end up with? X is equal to, I think it's 500 over what? Pi. Now, what's nice about this question, everybody, is it doesn't ask you what type of critical point it is. It doesn't ask you to do min or max. And there are no other values. Like, this is actually pretty straightforward as long as you divide properly at the end. But, no, I'll take what I can get. I'll take what I can get. Now, if I ask you for critical points, theoretically, if you had your calculator in this, what would I expect you to do? Take this value, plug it into the original equation. Now, you can find the y value. Let's see what we do. If we wanted to find this y value, we're not going to do it out, but if you had to, could you plug this x value into the original equation? What do you think? Could you?
Yes.
If you take this, you would have to take this x value and plug it in all over the place. So to get y, what would you have? Pi times 500 over pi squared plus pi times what? Oh, thank you. Pi times 1,000 over pi minus 500 over pi squared. Now, is that something you theoretically could do?
Yeah.
Do you think given time and really good focus, you could come up with an answer to that by hand? Come on, have some confidence. Yes, you have the tools to do that. You do. Now, is that something you really want to have to do? Not so much, right? I mean, what do you start doing this out, you end up with 500 squared over pi, and then you end up with pi times, like, okay, that's 2, you have to get, it's like you're kind of sad right there, right? But could you plug that into your calculator? Yes. Okay. So I will let you, if we have a calculator, do that on your calculator as long as you have how many decimal places?
3.
I want 3. 3. This is what we need to get to, though. This is what we need to get to. So what have we scaffolded towards? So it says, what's the shape, Chris? It's a rectangle, right? So you draw a shape, and then what do we do next? Someone new. What do Arvin? Yeah.
Say like circumference equal.
Well, we don't need, not circumference this time, because we don't have a circle. Perimeter. So perimeter equals what? 1,000. Okay. What do we need to label on this diagram? Side lengths, right? It's a rectangle, so do all the sides have to be the same length? No, but so therefore, what do we have to put up there at minimum? What do we have to put up there? 2 lengths, right? So what letters do you want to use?
L and W.
Yeah, so we could use W and L. How do you express perimeter? How do we express perimeter in terms of length and W? What's the...
2W plus 2L.
Thank you. 2W plus what?
2L.
2L. And look what it's asking for. It's asking for us to find the maximum... What's the largest area? What's the largest area? So we need to write an equation for what?
Area.
So area in terms of length and width is what, Andrew? What's the area in terms of length and width of a rectangle?
It's just length times width.
Exactly. Length times width. So we have 2 equations here. We have 2 equations. Which one are we trying to maximize? Which one are we trying to maximize? A equals LW, right? The challenge is L and W. That's 2 variables. We deal with equations that have 1 variable. How do we turn area into a single variable equation? Substitution, right? Absolutely, substitution. It's substitution. Well, we know from the first line, what is the perimeter? So we know 1,000 is equal to what? 2W plus? What can I divide everything by? Remember, we like smaller. So 500 is equal to W plus L. What do you want to isolate? You pick. Doesn't matter. It literally is the same work. W? So what does W equal?
500 minus L.
What do we do with that now?
Enter it back into the perimeter equation. Oh, area equation.
The area equation. So what is area now equal to? L times 500 minus L. We now have an equation. We want, what do we want? We want to maximize A, right? We want to find a maximum. So what do we need to take of this thing? We need to take the derivative. Before we take the derivative, somebody else said, what could I do before I take the derivative to make this nicer? Simplify it. Or multiply it out.
Yeah.
It's interesting. Like, in a way, it's unsimplified, but it makes the derivative easier.
We've talked about this before, but
Yeah.
I feel like it'd be, like, to me, it'd just be easier if L was X.
Yeah. Remember, depending on what letters you use, right? And I can guarantee more than half of you are going to use L, X, and Y, right?
I use L and W.
Some people do, but the point is you kind of get a little bit more uncomfortable when it's L and not X, right?
It makes you remember the rectangle length.
Exactly. So let's multiply this first. What do we get? 500L minus. So now we take the derivative because we want to find a critical point. We want to find a maximum. Someone, David, what's the derivative of this? What's the derivative?
500.
The last one, yeah, I was like, DT! I gotta put DT on there. No, we're not. There's nothing's moving here. Yeah, right. Okay. Is this not? Oh, we set it equal to what now? So 500 minus 2L, we want it to equal what? 0. So 500 equals 2L. So L is equal to 250. So this question asks for the length and width, right? Do we have a relationship between length and width on the board? What's at the top there? So what's W going to be? 250. So what shape do we actually have? Yeah, and that should theoretically make logical sense. What shape maximizes the amount of space you can put inside a fence area? A square. That should make sense. How would we verify that? What would we need to use in order to verify this? How do we verify something's a maximum? 250, right? And what's that derivative? What was that derivative? 500 minus 2L, right? A prime of L. So we do the derivative, right? A prime of, it's in terms of L. So we know the derivative is 0 when it's 250, right? This is the derivative. What's to the right of 250? Give me a number to the right of 250.
251.
251. Plug in 251 into for L. What do you get? Do you get a positive or a negative number?
Negative.
You get a negative number. Plug in something to the left of 250, say 200. What do you get?
Positive.
Positive. So what's going on here? It is rising and then, so it's definitely A. Now, why was this actually pretty nice of a problem for you? Why was this nice?
The numbers are easy.
A, the numbers were easy. What else? There's something else that was really nice about this problem. What? What? Nothing's moving. Okay, yeah, it's like, I'm not using multivariable calculus. Yeah, what?
There's no square root.
There's no square root. So algebraically, was this rather straightforward?
Yeah.
This was more of a do you remember the path question, right? The relationship, as it gets more complicated, what are we going to have to start using? Well, equations that look like the ones we just used, right? The relationships are going to be more challenging. But does the methodology change? Finding maxes and mins, what do? You find your equation, which is, in my opinion, usually the hardest part, and then what do you have to do? Take a derivative, set it equal to,
0.
and solve, and then check your answers, right? Sometimes it's annoying. Sometimes it's annoying. Okay, let's look at this one. This is a good quick one you can figure out. What if we had the exact same problem above, but for some reason the width had to be between 300 and 600? If the width had to be between 300 and 600, and you wanted to maximize the area, what do you think the width should be? If the pen had to have a width of 300, right? We know that it maximizes area when it's a what? Square, right? But let's say this was 300, right? That had to be 300, or it could go all the way up to 600 and 600. I'm giving you a hint by drawing these pictures here. Can the width be 600? Why not?
It
Exactly. So you actually can't do this, right? And what happens as the width gets bigger? What happens to the length? It gets skinnier and skinnier and skinnier, right? I'll give you the extreme. What happens if the width was 500? What would the area be?
0.
0, because the length would be 0. It would just be 500 and two 500-foot pieces of fencing next to each other, right? So which one do you think we should use? If we wanted to maximize this, 300 or closer to 600? 300, right? What would the length be if it was 300 and 300? 200 and 200. Exactly. So you can use logic on this. You can also look at the area function itself, graph it, and see.
So basically, you just want to go to
one of the extremes.
The number that's closest to the maximum.
If it's a rectangle, yes.
Okay.
If it's a rectangle,
okay.
It's going to change if it's a different shape. That's where different equations are going to come into play. Let's pick a different one. You have a wall in this case, and now your fencing does this. It's still a what shape? It's still a rectangle, right? So we called this one width, and we called this one length, right? Is that how we labeled it? Yeah, we had width and length. Yeah, we did that. Yeah.
Like perimeter will just
the perimeter is still 1,000, right?
Yeah.
But in this case, because the wall is free, we know the perimeter is now equal to what?
W plus 2L.
Hold on. Well, just it's W plus, like this is the fence right here. Here's the fence.
Yeah.
That's going to be, how many L's is that? 2 of them, and how many W's? 1. There's only one width now, right? Because you don't need to do the other one. You don't need to do the other one. Do the same thing now for me. Find me the dimensions that will maximize the area. I'm not doing anything else. I'm not going to give you anything else here. We got W is equal to 1,000 minus 2L, I think. Is that correct? Take a look at the board because I have to let you go in a minute here. What happens? Where do I plug that W in? I plug it into the... Oh, area is equal to length times width. Sorry, I went looking for an equation that I didn't have. Sorry. So what do you have? Area is equal to L times 1,000 minus 2L. So area is equal to 1,000 L minus what? So now you take the 1,000 minus 4L, and then you set it equal to 0. So you have 1,000 equals, so what does L equal this time? 250. So if this is 250, this is 250. So what's the width going to be this time? 500.
That makes sense.
Makes a little bit more sense, right? So what I really want you to focus on, everybody, is make sure you understand what these the word problems are asking you on the homework. You have 2 of these to do, which is solving equations and doing these word problems. Get comfortable with solving the equations. You don't have to do all of them, but really focus on the second one, which is the these min-max questions for homework tonight.